11 at 10.
Did you get joined now?
Yeah.
Okay.
All right, welcome everyone. I hope we have everybody here. We'll just give a few more minutes for a few more people to join and then we'll get started. Just wondering, are any of you guys in a boardroom with more people? Okay, sounds good. So are Tim and Courtney joining, would you know, or should we just begin? Uh, Sure. All right, sounds good. Okay, everybody, welcome to this pallet rack safety training. Our company is called Damotech. We are the first and the largest rack safety solution specialist in North America, and we provide racking assessment and repair services. Myself, my name is Hamza Amir. I'm an engineer in training, and I'm working towards becoming a licensed mechanical engineer in Canada. Along with safety trainings, I regularly perform racking inspections, so I have ample amount of experience to share with you guys today here. Along with me, I also have Mikael on the call. He's one of the team lead. He's also an engineer. Um, he has a lot of experience and knowledge of racking industry. He won't be talking today, but he will be looking at the chat to answer any questions you guys have. So throughout the presentation, if you guys are unsure of something I have said or you have any general questions, feel free to drop them in the chat and he'll be happy to answer. Agenda for today. We'll start the presentation with discussing why inspections are critical. Then I'll go through our rack safety flywheel, which is an in-house system that we've developed for inspections and safety. Then I'll go into the first main component of this presentation, which are some fundamentals of power racking, just to make sure we have the nomenclature. After that, we'll dive into the first major section, which is how to identify issues. That will be followed by a quiz, and then we'll take a short break, 10-minute break. Once you're back from the break, we'll dive into the second major component of this presentation, which is how to prioritize issues. That will be followed with a quiz, and then we'll go into how you can develop your own inspection protocols, and I'll show you guys some tools, and then what are some of the solutions that we offer for rack repair and replacements, and then we'll end off with how it's important that you view both people and the product, your racks, as assets. Starting off here, what we see is we have some custom rack repair solutions. As you can see on the top left, we see our rack here wrapped in plastic. We can't be 100% sure as to why. It may be to hold this column in its place, or maybe to hold a protector. But one thing is sure, this is not an optimal solution, because over here you see that the column is twisted at the bottom, and looks like the protector is loose. And having a shrink wrap around the upright is not even a temporary solution, because this is very, this is very short term. So this is not the way to go. Another example of an in-house operation, as you can see here, the column at the base is damaged and also at the back. And for some reason, this company decided to install a wooden plank as a protector in the front. But it looks like the forklift fork came into contact and already damaged the wooden plank. So again, this was of no use. Another example of an in-house operation that we have seen, as you can see, the column here is deformed, and they decided to apply two wooden planks on each side and nail them into the column to protect either the column or increase its shelf life. But again, this is not an optimal solution. It will not go any long term. These are some of the examples of in-house operations we have seen which are not effective at all, because with these small in-house fixes, you might have a relief for a day or two, but overall in long term, it's not the optimal solution you're looking for. So you might ask yourself here, why are we doing this training and why is it important? So looking at this example here, before this rack system actually collapsed, this facility performed an internal inspection, and they found that there is damage on this blue upright. So they gave us a call at Damotech. We went in, we took our inspector took the inspection, he took the assessment and took all the measurements. And before we left the site, we advised the the manager on site that, hey, we should unload all of the beams as there's severe damage on this column, and you shouldn't use these racks until or unless it is repaired. Before we got the chance to fix it, the client actually decided to keep using it, and lo and behold, the racking system actually collapsed. Luckily, no one was injured, but as you can see, the upright over here is, it previously was severely damaged. It was deformed, but now it looks like it's sheared off. The beam here is deformed and is broken. The clips are broken, not just for this beam, for multiple beams. It looks like some of the product may have gone to waste because it is no longer usable. As you can see, just because they ignored a simple advice which could have saved them thousands of dollars, they kept deciding to use the rack and not do the repair, and it costed them a lot more. So this is the reason why rack safety is important. Anytime a professional comes in and gives you the advice or a suggestion that you should unload and repair, you should take it, just because in the long term it will save you more. So in the next couple of slides, I'm going to show you some videos of some of the rack collapse which have happened, either due to damage being ignored or due to internal damage or seismic events which are not controllable. Again, these are real life events, so viewer discretion is strongly advised. Starting with the video on the left. As you can see here, the rack system actually starts collapsing at the back right here. Then it makes its way forward, then it goes around. The reason for that is because the racks are inherent structures which are connected to each other by cross allies. So if one system falls, it actually pulls the neighboring systems down, in a domino effect, and this is normally seen across all the racks in all the industries. The picture on the right is another example. It looks like this rack system had a impact from a forklift or some kind of collision. As a result, this entire system fell onto the neighboring system, and this fell on the following, and then kept going. Not only the rack systems got damaged, but looks like the product also went to waste. Again, thousands of dollars of loss. Here you see that the rack is vibrating, and you see a gentleman running out because he senses danger. And soon, everything goes downhill from there. Over here, you can see the rack is shaking, so this basically implies that there is probably any internal damage, because anytime in seismic areas, when racks are installed, they're installed with special care, as some of their components are with higher strength, and there's some anchor and base plate requirements which need to be met. So the vibrations may signify that it is internal damage which was not corrected, or which is not repaired on timely manner, resulting in such a collision. But again, there could be a lot of possibilities. Maybe overloading is one of them. We are unsure, but this is an example of a collapse which can happen in seismic events if there is damage. Here, this signifies the importance of how minor impacts in damage-prone areas can result in great consequences. You can see that the forklift driver, he was very careful, when he was driving, and he just barely touched the rack. It looks like it was not even a major hit, and everything comes down. Again, triggering that domino effect, all the racks come down, tumbling on him. In this next video, you can see that the forklift driver was trying to squeeze through for some reason, and then he makes a small bump on the upright on the right, and he gets buried under the product and the shelves. All in all, accidents like these are preventable with the right know-how. That's why we're taking the time to train everyone today, so that everyone understands how you can identify issues, and more importantly, what are the actions you can take to find the problem to help resolve disasters like these from happening. So essentially, that's the reason why we're doing this power rack safety training. Now let us turn our attention to the rack safety flywheel. Rack safety flywheel is a framework that we at Damotech have developed. It is a tool that serves as a comprehensive guide for establishing and maintaining a robust rack system program. So it covers everything from the benefits of having a rack safety program into specific action items you'll need to implement. So we'll be incorporating this flywheel into various parts of our training today. So I'll show you how each component fits in the bigger picture. But as a brief summary, rack safety is fulfilled with employee well-being, operational efficiency, and compliance. If the employees are all kept well, if you have operational efficiency and there's compliance, that is a sign that your racks are in a good condition. And that can be achieved with either in-house knowledge or third-party expertise. For example, if you look at third-party expertise, it could be, first of all, doing some inspections. With inspections, you have some insights. Using your insights, you develop a maintenance program through which you develop a prevention program. And if you want to go into detail, for example, inspection, you can have like independent inspections or self-assessments. So you can be third party, or you can do in-house. For insights, it can be engineering reports, like for example, from Damotech, or you can be tracking and planning for your own um, uh, company or warehouse department. For maintenance, it could be damage repair, or it could be component replacement. And prevention, it could be protecting solutions, for example, demo guards or some kind of guards in front of the rack, or could be educational safety sessions, for example. This is one of them. So that's how you incorporate rack safety flywheel into your warehouse. I'll go into a bit more detail in how if this fits into the bigger picture later on. So diving into the fundamentals, just before we dive into the major chunk, I just want to make sure we're all on the same page and we all understand the nomenclature, so that later on when we're discussing racks, we're sure as to what components we're talking about. Just some things that across North America, governments require their employers maintain a safe working environment for their employees, and the improper use, selection, and installation of maintenance of racks and storage systems puts the worker at risk of injury. So again, if you know about something and you don't report it, nor do you act, and somebody does get hurt, you can get sued, and it is a criminal level offense. So it's important that whenever you find any damage or someone gets hurt, you report it and address the issue as soon as possible. There are two design codes which are used in the racking industry primarily. Number one is CSA 345, that is the national standard of Canada. And in the US, we have ANSI MH 16.1, 2023. So for you guys, since you guys are located in America, it will be ANSI 16.1. Here, the ANSI 16.1 is a design specifications code for racking systems. It's been there for over 3 decades. Initially, it was there were recommendations set forth by the RMI, which stands for the Rack Manufacturing Institute. But in 2012, there were significant shifts. So these recommendations were elevated to American Approved National Standard. So that's what it stands. ANSI stands for that one. In this standard, you'll find a lot of different information that might be useful. For example, you can go into general materials, like materials that you need for your racking. If you go into loading, what are the load combinations and what are the load impacts? If you want to go into that, you can go into design. It could be upright beam, it could be column design, frame design, and some of the test methods. So there's a lot of information that if you need for designing, it comes through this standard. While the ANSI MH16.1 design specifications are primarily for rack designers, for those involved in everyday warehouse operations, who seek a more hands-on guidance, this is where RMI's user guide comes in handy. Unlike the design specification, this is not a code, but it's a practical guide. It offers actionable insights and considerations. For example, if you need help on planning or purchasing considerations, like for example, if you want to purchase racks for a specific location, this rack can be handy. If you need help in designing and using racks or inspecting maintenance or general repairs, this guide is perfect. So for all the warehouse employees, this is the way to go. Let's briefly discuss some seismic hazards in the United States. So as indicated on this map, many of us are aware that the West Coast experiences significant seismic activity, especially the from California all the way up to Alaska, and even extending to Hawaii. When you compare, racking high seismic zones to low seismic zones, you'll notice that there are notable differences. For example, for racks in California, they're often thicker and they use higher strength steel. As well, larger anchors are also required, and it is mandatory to have multiple anchors installed. Whereas in non-seismic areas, the steel gauge is a standard steel and the anchorage is just one anchor per base plate. So in high seismic zones, we take a rigor approach because they're more prone to collapsing just because of more seismic activities. Um, and I'll dive into a bit more detail as to different measures we take for seismic zones later on in the slides. Okay, so diving into the nomenclature, what we see on the left here is called a one-bay rack system. A rack system is a complete assembly of components designed to hold materials or pallets. Moving to the right, we have a lateral view of the blue structure, and this is known as an upright. An upright is made up of several different components. Starting off, an upright is made up of a column, so you can have back column and the front column. So an upright has two columns. Then it is made up of horizontal braces, and then it has diagonal braces. It also has a base plate, which is used to attach the column to the floor, and an anchor, which is used to secure the base plate to the floor. In terms of holding and supporting pallets, what we have are these structures in orange are called beams. Each beam has beam clip, one on the left and one on the right end to engage with an upright. And there are two beams, one in the front, one in the back. And to support pallets, we have safety bars, which is to prevent pallets and products from falling through. Now, if you take a look at a slightly larger system, all the volume between two uprights is called a bay. And here we see that this bay has 4 beam levels. So 1, 2, 3, 4. On the side of the first upright, you'll notice an example of a load capacity plaque. For example, right here in here. These plaques are typically present when the configuration of the racking system is uniform. So in other words, if the beam and uprights are consistent throughout the system, it could be that the beams that we have here are at the same level and the same dimensions, and likewise for the upright. Then we can have this plaque indicating the load capacities at the end of an aisle. If you zoom into one bay, let's say we zoom into the top, into this middle bay and this top area, the volume between two uprights and two beam levels is called a cell. So previously we defined that the volume between two uprights is called a bay. Now the volume between two uprights and two beam levels specifically is called a cell. A quick recap. Here we have a system which is made up of 3 bays. And the volume between 2 bays and 2 beam levels is called a cell. In here, this orange components are called beams. And the blue components are called uprights. And this rack system is made up of 4 different uprights and it has 4 beam levels. Now you might ask yourself, hey, where do these racks actually come from? So racking is manufactured in 2 different ways. Number 1 is hot rolled, and number 2 is cold rolled. So for hot rolled structural shapes, how it works is you have a hot roll sheet that comes out of the furnace. This hot rolled sheet is then put through these rollers, and these rollers create the desired shape of the upright that you want. As you can see here, you can have multiple different type of shapes that you can generate through the rolling system. In the top are the I shapes, the W, M, and S and HV shapes. Then you have the C shapes, which are called the structural steel. After that, you have other shapes, for example, the HSS, the hollow structural steel, and then you also have the L and TS and HSS shapes. Again, these shapes, you have different types of shapes that you can create through hot rolled production method. And the other method that you have to produce racking is cold rolled. The difference between hot rolled and cold rolled is that in cold rolled, you start with a sheet at room temperature. It's a big sheet. What you do is you put that sheet through a furnace. Once it comes out, you wait for it to cool down. And once the sheet is cooled, you then roll it into a coil. Once that coil is rolled, you place that coil at the start of this machine. First, it uncoils that sheet. Then it goes through a punch process where it creates a punch of the desired shape that you want for your rack. And then it goes through the rollers to create the desired shape that you want. In the next slide, I'll show you some examples of the racking that you can produce from based on the different types of production method. So these are the type of shapes we can normally get for upright components. On the left here, we have structural columns, which are able to identify right away based on their C shapes, and these are one of the more stronger columns you can find in warehousing. Now looking at the cold form steel on the right side, you can see that there are literally hundreds of different column styles out there, and the reason for that is because each column type is protected by a patent, so the other companies can't copy the manufacturer's specific column style. And cold form steel allows you to create different variations in different shapes. So that's the advantages and disadvantages of these 2 methods. Now I'll go into describing different type of racks we find in a warehouse. Overall, there are 2 categories of racks: static and dynamic. Static racks, there are either frontal loaded, or there are, okay, for example, for frontal loaded, for first category of racks, you have single deep racks. Single deep racks are the basic type of racks you find in most of the warehousing. In here, the uprights and the pallets are stored only from the front, and you can only have one pallet per location. Another example of racks you find in the warehouse are double deep. Double deeps are similar to single deep, except you can instead now place two pallets in one location in two different depths. For example, here you can see in this location you can have two pallets, so it gives you more space. Second type of racks for static is static accumulation. For example, drive-ins and drive-throughs. The difference between drive-in and drive-through racks is that for drive-in racks, there's only one entry and exit point. So if you want to store non-perishable products, drive-in racks is not the way to go because it will not follow first in, first out. It will be first in, last out. As you can see, there's only one entry point and one exit point. Whereas for drive-through, there's one entry point in the front and a separate exit point from the back. So if you want to store perishable products, this will follow FIFO, first in, first out. So you will be able to rotate the inventory based on your best before dates. While we're here, I just want to discuss safe unloading and loading methods for driving systems. The idea is that whenever we're unloading, we want to make sure we're never underneath the product, and also when we're loading, we want to make sure we're also never underneath the product. So let's say we are unloading. Let's say we want to retrieve pallet number 11. The safe method to do that would be first you remove pallet number 1, pallet 2, pallet 3, pallet 4. 5, 6, 7, 8, and 9, 10, and then you remove pallet number 11. This is just to make sure you're never underneath the pallets. And likewise, if you want to retrieve pallet number 4, best and the safest method would be to remove pallets 1, 2, 3, and then you remove number 4. This is just to ensure nobody's underneath these pallets at any time. The second family of racks that we have are gravity operated. For example, pallet flow is one of them. So the way pallet flow racks work is you have a racking system where these rollers are on an incline, and you have one entry point and a different exit point. So what happens on the top end of the incline from the back, once you load the pallet onto the rollers, through the rollers braking system and the speed, the pallet actually slides down. And once it comes on the other end, there are these pallet stoppers which hold the pallet in its place. And then if you want to retrieve this pallet, you can just pick up the pallet from here. For this system, it's very important that the braking system of these rollers is controlled and is well maintained, because if the rollers are moving at a very high speed, let's assume this is not the first ground level, this is like a second level. If the rollers are moving at a very fast speed and the pallet comes running down, once it hits the pallet stoppers, you can topple over, it can injure someone. So that's why it's very important that these rollers are controlled in terms of their speed and they're well maintained. Second category of gravity are pushback systems. Similar to drive-ins, there's only one entry and exit point. So if you want to store perishable products, this might not be suitable. So the way these are operated is you have gravity operated carts. So first, once the pallet comes in, the pallet is stored on the cart, and the cart is then pushed back and it makes space for other pallets to be stored on these rails. Unlike pallet flow, which is operated using rollers, these are operating using carts and rollers. For the dynamic category, aside from gravity, you also have mobile racks. The way these mobile racks work are they're operated using these guidelines on the floor, and they're all electrically controlled through the click of a button. These racks are very compact, and they're not very normally found in warehousing. Only warehousing which are very short on space and they have a high budget, they tend to go with a solution because it can be very, very costly. But this is one of the example of racks you find in warehouses. So just a quick recap, pallet racks, we have two families, static and dynamic. For static, for frontal, we have single deep and double deep. For static accumulation, we have drive-ins and drive-throughs. For dynamic category, we have gravity operated, such as pallet flow and pushback, and then we have mobile racks. So these are the 7 type of racks which we normally find in warehouses. All right, now that we've gone through the nomenclature, let's dive into the first major component section, which is how to identify issues. The first question we want to ask is, what are we looking for? This can be broken down into three main points. Number one, uprights. Number two, beams. And number three, larks. Whenever we're looking at uprights, we want to look for damages. And then we want to look for damages to the upright. It could be the front, back, column, top, bottom, wherever it could be. It could be, damage to the braces. And it could be looking at base plates and anchors. Are base plates damaged or the anchors missing? For beams, likewise, we want to look for any damage, any deviation. We want to look for missing beam clips or missing safety pins, and any missing safety bars or wire mesh in a tunnel environment. For large, we want to look for any load capacities to make sure they're displayed. And if they are not displayed, then we want to make sure they are present. Here at Damotech, we have developed a simplified practical guide to rack damage assessment that you can find on our website. We also have this in a print form, like a pocket size format, so you can carry it with you to inspect while you're at your facility. And actually, most of what we're going to look at in this section of this presentation is in this guide. So it's a great help. If you guys want to, you can download it from the website and use it in your warehouse. Okay, now let us get into a bit more detail with respect to all these points. So starting off with upright, in the next few slides, what I'll do is I'll focus a bit into more detail into each of this component. But for now, what I want to go through is for upright issues, some of the things we got to look for are dents and deflections. This could be, sides, front, back. It could be verticality. Is it leaning to the front, back, left, right? It could be clearance issue, clearance with the wall or the building wall, or clearance between the product and the upright. Or we can have like a height to depth ratio, which comes from the racks. Or it could be that there's damage to the braces, or it could be that anchors, both shims are missing, or it could be a rust issue. So these are the type of issues that we look at on upright normally, and I'll go into a bit more detail starting now. Starting off, you might ask yourself, hey, we have damage on the rack, but how do we know that we have to take action with regards to this damage, and how much damage is enough and how much damage is not enough? Well, for that, we have a guide that you can apply. It's called a 1, 2, 3 rule. It says that if you have damage which is greater than 1/8 of an inch on the frontal side of on a column, for example here, then you're going to take action. And it says if you have damage greater than 2/8 of an inch on the lateral side, you're going to take action. And likewise, if you have damage greater than 3/8 of an inch on the brace of an upright, then you are going to take action. Anything below these values for these different inspection points, you're probably still okay to keep the rack operational. But the truth is there are many factors at play when assessing deflection. So though following this general guideline, you should be able to determine whether this column needs to be repaired or not. It's a great tool and you should stick to it. But if the damage is actually twice of these values, let's say the frontal damage is not 1/8 of an inch, but instead twice, so it's 2/8 of an inch, which is like 1/4, then that means you need to repair or replace that upright as soon as possible, ASAP. Or it could also be an unload situation, which I'll give examples of later on. But in general, this is the rules 1, 2, 3 rule guideline which you need to follow for damage. Another issue we got to look for is auto plumb or verticality. So this is telling us whether the rack is leaning to the front, back, left, or right. In general, the rule of thumb is you're allowed a maximum of 1/2 inch of deflection per 10 feet of height. So if at 10 feet, you measure your deflection is greater than 1/2 inch, then you got to take action. You got to remove product from the shelf and re-plumb it and bring the upright back into plumb. It's important that you correct this issue because if the system remains out of plumb for a long time, it can result in permanent damage and permanent deflection on the beam and the upright. So that's why it's very important that you address this issue as soon as possible. Clearances. In general, pallet racks are structures designed to be self-supportive and freestanding. Building walls and building components are not typically designed to support additional loads from neighboring structures. So anytime you have pallet racks or you're connecting to the building wall, it allows you to transfer forces between them, which could have unintended consequences. So, for example, if there's an earthquake and the building, if the system is a upright is attached to the building, then it's possible that the building is passing on its forces, passing on the load or the vibrations to the upright, and it can cause the upright to collapse. So that's why it is not recommended that you install that you connect a pallet rack to the building wall unless you have a building engineer who comes in and verifies and says you're okay. Otherwise, it is not recommended. In terms of clearance, the code specifies simply that you, for down aisle, you need to make sure you have at least 5% of the height of the last beam. And then for down aisle, you need to make sure you have at least 2% of clearance of the height of the last beam for cross aisle. So what that means is, for example, if you look here, if you have this H height of this beam, which if you have this beam which is 100 feet, 100 inches, sorry, that means you need to make sure you have at least 5 inches of clearance down aisle and 2 inches of clearance cross aisle. This is just to make sure that if there, in case there are seismic events or seismic activity, you have enough wiggle room for the upright to move and it will not make in contact with the wall. The codes also specify that if you have racks and if your rack has a height to depth ratio below 6, then you are still okay. In cases where your ratio is higher than 6, you need to take special considerations to anchor or laterally support the racks, which must be done by an engineer. One good way to handle this is by adding row spaces into systems. So height to depth ratio is basically a simple calculation of taking the height of the entire upright or taking the height of the upright to the top beam level. As you can see, this is the top beam and divided by the depth of the upright. So if this height divided by depth is below 6, then you need to take action to bring it down to 6. Let's say it is below 6. What you can do is attach row spacers between these two systems. So by adding row spacers, you're actually connecting these two uprights. So the depth actually doubles, and plus the row spacer, it increases by about 2.5. As a result, if the height previously was height to depth ratio was below 6, now higher than 6, now it will be below 6 because the depth has doubled more than twice. In terms of braces, braces are very important members on an upright frame. Some issues we need to look for braces are either missing or detached bracing. For an untrained professional, it is very common that we find in warehousing anytime you have a missing brace, it is not really identified. In general, in essence, for uprights, the way bracing structure is created is you have a horizontal brace and then a diagonal, then a horizontal, then a diagonal. So anytime you find that there's no diagonal brace, most likely it is that it is an issue because it is missing and you need to install a brace. Pallet racks, they must all be anchored to the floor. We want to make sure that the anchors are properly tightened and there is a minimum of 1 anchor per base plate, as that is a requirement. Unless there are special considerations which are given by manufacturers, like for example, some kind of base plates require 2 anchors per base plate in like seismic zones. But however, every base plate must have 1 anchor per base plate. And in terms of anchors, there are 2 types of anchors that we normally find in a warehouse. Number 1 is an expansion anchor, or another name for that is a wedge anchor, and number 2 is a screw anchor. Expansion anchor is very common. We see it all over. It's cheap, it's distributed worldwide, and it's easy to get. Whereas screw anchor is much more stronger in both tensile and shear resistance, and it is hard to find. And one main advantage of a screw anchor over an expansion or wedge anchor is a screw anchor can easily be unscrewed in case you need to relocate, whereas for expansion, once installed, it has to be cut off and then you need to install a new anchor. Of course, screw is more expensive, but there are the benefits added with the cost. Another thing is whenever you have a floor which is uneven, it will most likely result in the upright being out of plumb. In that case, you need to make sure you install shims underneath the base plate of the upright. And when you are installing shims, you need to make sure that the shims are the same size as the column base plate. And also you need to make sure that the shims are tightened together and the height does not exceed twice the diameter of the anchor. This is important just to make sure that the shims are held in place and they're not easily twisted. And in case where once you install shims and you see the shims are twisted, you can put them back into their place by a hammering process. Rust is another big thing that you look for when you're inspecting racks. There are very bad cases of rust we'll come across in our inspections. As you can see here, these are two examples of rust we've come across, and both of these were unloaded because the damage is quite severe. On the picture on the left, you can see the rust has eaten through the steel, and there are flakes all over. Again, here this signifies that this is significant amount of rust, and the customer ignored this for a while and result in this condition. On the right, we see there was a component attached to the front, and because it was attached to the front, it was hiding the damage at the back, and on the background, the rust was eating through the steel. And once we removed that component, we figured it has eaten through the steel. Again, unloaded that right away and put in a repair um, process for this, just to make sure everything is good. You might ask yourself, hey, how much rust is enough, and how do you know that we need to take action? A general rule of thumb is that if more than 10% of the steel thickness is rusted, it's time you're going to go for a repair or replacement. Measuring that 10% can be challenging, so there's a simple trick that we use, and that is a screwdriver hack. So what we do is we use a screwdriver and then we scrape off. So for example, we'll use a screwdriver and chip away. If the chips are falling off similar to this, that means it's significant rust. You need to unload and replace. But if you have rust coming out as fine powder, that just indicates is this surface level rust. It is less concerning, but you can create a small issue. But keep in mind that if there's surface level rust today and you don't maintain it, then in future it can result in significant rust similar to this. And then if you're using screwdrivers, as I previously mentioned, if it's coming off as flakes or is peeling off easily, again, unload right away. The thing about rust is that most of the rust is usually found in uprights is usually around the base, and a lot of the times it is hidden. Either there are product there or there's some protectors or there's some base plate connections. So it's very important that whenever we are inspecting those areas, we are rigorous about the base of the uprights, especially in areas which are exposed to water, humidity, chemicals, and racks in their exterior setting. Okay, now that we completed everything with uprights, let's discuss beams. For beams, some of the things we gotta discuss today are vertical deflection, connectors, like are connectors present, safety pins are the missing, safety bars are why are they important, and pallets. What is the damage we find for pallets? Starting out with the vertical deflection, when we have beams, you're allowed a maximum of half an inch of deflection per 180 feet. That's the general rule of thumb. So for L over 180, that's the rule. If you have deflection, like L over, say, let's say the length of this beam is 96 inches. So 96 divided by 180 is half an inch. That means you're allowed a maximum of half an inch of deflection for this beam. Anything beyond this will require you to unload and repair that beam because it will indicate that this is permanent deflection. But as long as this deflection is within half an inch as maximum, then this will be elastic, which means that once you remove this product from the shelf, the beam will bounce back into its original position. So that's what's very important that you respect this rule. Likewise, if you take another example of a beam of 120 inches beam, for that 120 inches, maximum deflection allowed is 5/8 of an inch. For beam issues, some of the things we got to look for are number one, pierced and severely dented. So you can have beams which are either pierced from the front or pierced from the back. Again, if you find any the beams are pierced, then you need to take action right away because a beam which is pierced means their capacity is also jeopardized. Similar to uprights where we had the 1, 2, 3 rule, for beam, the rule we follow is 1/4 of an inch deep. If you see frontal damage more than 1/4 of an inch, that means you're going to take action. Anything twice that value, like half an inch of deflection, you're going to take action immediately. Anything below this, you're still probably okay, but keep a check on the damage. Connectors, you need to make sure that the connectors are engaged with the upright and they're properly welded to the beam, because connectors are essential component that connects the beams to the upright. If there's any damage to the connector, anytime a product is loaded, uh, the beam can fall because there was a damage which was not addressed in a timely manner. So that's very important that whenever you're looking at connectors, aside from the connection, you also look at the beam clips. If the beam clips are damaged and they're not able to engage with an upright, again, you're going to replace that beam just to make sure you prevent any future damage. And in terms of permanent deflection, as I previously mentioned, if you have if you don't follow the L over 180, if the deflection exceeds L over 180, then you're going to have permanent deflection, which means you need to replace the beam as soon as possible. Safety pins, there are small but mandatory safety device which is used to prevent beams from dislodging. Therefore, whenever you have beams, you need to make sure you have at least one safety pin in place for each beam level. As you can see here, this is an example of a safety pin that the client is installing for this beam, which was missing a safety pin. A general rule of thumb for safety pins is that you need to make sure that every safety pin is able to withstand at least 1,000 pounds of uplift force. And in our inspection of the warehousing, we've come across many different types of safety pins. For example, nut and bolt is one of them. J pin is the most commonly found one, and then you have stamped safety pins. In our recommendation, we always recommend that you go with nut and bolt, just because whenever there is any small collision or some damage from the upright or the pallets, the beam will not fall out of its place because it's locked in secured. Whereas for J pins, if there are vibrations, if the beam is hit, then there's a possibility that they pop out. So that's why it's very important, and our good recommendation that we give is nut and bolt is the way to go. Safety bars, similar to safety pins, these are a highly recommended tool in terms of the safety item, but they're not mandatory. For safety pins, as I said, they were mandatory, but safety bars are not mandatory in the North American codes. So if you do have them, then it is very important that you have 2 safety bars per pallet position, as that is something which the codes mention, and it is to hold the pallet in its place to prevent any products from falling. And you also need to make sure that if you do have safety bars, they are installed both in the front and the back. For box beams, you can attach them using screws, and for step beams, you can attach them using clips. In terms of damaged pallets, what we look for, as you can see, pallets can have a lot of damage, a lot of different types. You can have glass, you can have cracks, nails sticking out, sharp edges, or you can have a board overhang. This example on the right, you can see that the bottom plank of this wooden pallet is broken. Again, these pallets are rather cheap, so they're easy to repair. So in situations like these, we recommend that you remove this pallet and move the product to a different pallet, and use a new pallet, because pallet damages like these can result in injuries at work, and we want to prevent that because that all comes under safety. Now I'll talk a bit briefly on clearances. In general, you need to make sure you have at least 3 inches of clearance between the loads and the column. So previously in the previous slides, I talked about clearance between the rack and the building wall. Here we're talking about clearance between the rack and the product stored in the rack. So you need at least 3 inches of clearance between the load and the column, likewise between the load and the beams above. And you need to make sure you have at least 4 inches of clearance between the loads placed in back-to-back cells. So let's say you have these 2 single leaps, you need to make sure the gap between the product is at least 4 inches, just to give them a wiggle room to move the product. And once a product is stored on a beam level, you need to make sure you have at least 2 to 4 inches of pallet overhang, both in the front and the back. Not less than that, because if it's less than that, then the product can fall through. and now more than that because again the product can fall through either from the front or the back. Now, as I go through these images, you'll notice examples of some homemade welded repairs that we have come across during our inspections. While these might seem like quick fixes, they often come with significant risks. Field welding or welding on existing racks might appear to be a cost-effective solution, as you can see here and here. But however, there are considerable risk factors to consider. Not only there is potential fire hazards, but there are also risk of weld contamination. Repairs like these, like DIYs, are not recommended. We also always recommend that anytime you need to have welds, you have them executed by a certified welder, or you call the OEM and ask them to come and do the weld repair. Because it's very important to understand anytime you have DIY welds, it does jeopardize the load capacity. So let's assume that before this damage, your load capacity for this beam or this upper rack was 2,000 pounds. And now that you have done in-house welding, it might have reduced the capacity by 1,000 pounds and you're still loading it at 2,000 pounds. It can result in a rack failure. So that's what's very important, that anytime you need to do weld, you don't do any in-house welding, but you go through a certified welder and OEM. And whenever you do that, you need to call in a professional to have your racks recertified. Again, safety is a big thing in the warehouse, and it doesn't only come through rack, it also comes through employees. So you, as an employer, you need to ensure that all your product is stored in conditions where it prevents them from falling through. So whenever you have racks stored, we always recommend that you install wire mesh decking. And then anytime you have a tunnel, is important. It's mandatory that you install wire mesh decking. That's one of the requirements for North America. Anytime you have tunnels where people are walking through, either it's an exit way or going from one location to another, you must have wire mesh decking. But aside from tunnel, wire mesh decking is recommended. It is not a requirement. Floor forklift trucks. It's important that you control how forklift trucks are moved and making sure you have proper guidelines, just to make sure that employers ensure they know that there's forklift in the area, just to prevent any accidents from happening. Workstations, you want to make sure you install them out of traffic, keep them in a corner and have it barricaded with bollards, or have some kind of precautionary equipment installed in place to prevent any forklift from coming close to or in contact with the workstations. Like also work platforms, anytime you have work platforms, you need to make sure you have what is it called? You have guardrails installed. Another name for work platforms is mezzanines. So anytime you're storing product on the top, there's a chance that the product may fall over. So it's important that you install guardrails just to prevent any injuries. Also, if you have racks, again, racks are part of the building, and so building and fire codes need to be adhered to. As you know, safety is paramount, and these codes are in place. So anytime you have racks, make sure the racks installation team and wherever the racks are installed, they're abiding by the building and the fire codes. Now that we're finished with uprights and beams, let's go into load capacity. The code does not actually enforce any particular model, but rather imposes that the label or the plaque must be visible and it must coincide with the load application or rack configuration drawing, also known as LAR. So looking at the load capacity label photo on the right, we can see that it displays 5,000 pounds on this level. And also this 5,000 pounds for this beam level is per pair of beams. On this capacity label also gives you the different heights of the beams. For example, it reads I think 60, 40, and 40 and 42. So these are the gaps between the beams. So first beam is at 60 inches from the floor. Second beam is from the second beam is 4 inches from the first beam, and third beam is 42 inches from the first beam. So these are the gaps that it tells you. It also gives you the information of the manufacturer who provided you with the capacity in case you need to contact them. Again, very important that anytime you have these low capacity plaques or these labels, they must coincide with the LARCs to make sure there's no discrepancy. Low capacity plaques, they should be visible and they should coincide with LARCs, as I mentioned. So if a system is uniform, let's say you have a system which has three bays, you have four uprights and three beam levels. If they're repeated, if the beams are all at the same level and they're the same size and the uprights are exactly the same, then instead of having a load capacity sticker, you can have a load capacity plaque at the end of a aisle. This just makes it easier because if everything is uniform, everything will be the same. So every system and every bay will have the same capacity. As you can see in this low capacity plaque, it gives you all the different information you need to know. For example, for the first beam level, it tells you this is the capacity for this picking beam. Second beam level gives you the capacity per each pair of beams. So 2,000 pounds for each beam, for each pallet. Likewise for the third beam level, it tells you 2,500 pounds for each pallet and total 5,000 pounds per beam. It also gives you some warning, so do not climb the structure, report all damage, any caution. It gives you the name of the manufacturer, and it gives you overall the capacities for the entire system. So again, it's a great tool if your system is completely uniform, but if it's not uniform, then the way to go is low capacity labels. Here, we have created this little video to help you understand the dangers of playing with beam elevations. So we made this rack model out of a foam core. As you can see, let me play that for you. So this model is made of a foam core. You can see we're placing heavy 3x3 steel plates on top of the beam level. Here, the rack model currently is stable. As you can see, everything looks very neat. Now you see that we are removing the bottom beam level without contacting an engineer. Now, as we load the beam levels, somebody's holding the rack system because it is very unstable. And we haven't even finished loading the second beam level before the rack actually collapses. What happened here was that by removing the first beam level, we diminished the load capacity of the rack by a factor of 4. What it is important to remember is that by modifying the original configuration of the rack, such as moving a beam height or removing a beam without an engineer's approval, it can result in a weakened structures, increasing the risk of those around you. So in essence, anytime you remove a beam, you need to make sure you call in an engineer and have, or anytime you move or remove a beam, you need to call in your engineer to have the capacities recalculated, just to make sure you're storing your product within the capacity limits and not causing any damage or injuries. All right, now that we've gone through the first major section, let's do a quick recap. In terms of damage of an upright, we follow the 1-2-3 rule. So 1/8 of an inch for the front, 2/8 of an inch for lateral, 3/8 of an inch for brace damage. Anything twice is an unload, and anything less than that, you're still okay. For verticality, the rule of thumb is half an inch over 10 feet. Anchors, you need to make sure you have at least one anchor per base plate. Damaged beam connectors and safety pins. Damaged beams, the standard rule is 1/4 of an inch of deflection. Anything twice than that, half an inch, is an unload and ASAP fix. Connectors, you need to make sure the connectors are able to engage the up beam to the uprights, and the connector pins are not damaged, and safety pins are a mandatory item. You need to have at least one safety pin for each connector. Anytime you have damaged pallets, you need to replace them, and anytime you decide to install safety bars, you need to make sure you have at least 2 for correct pallet positioning. I just mentioned safety bars are a recommended item, not a mandatory. So anytime you do install safety bars, you need to have at least 2 per each pallet, and they must be secured to the front and the back using bolts. And wire mesh decking is recommended, but for tunnels, it is a necessity. It is a must. So anytime you have tunnel, like an exit, emergency exit, or you're moving from the warehouse to the office and there's a tunnel, you must install a wire mesh decking to prevent product from falling through. Load capacity displayed. Load capacity should always be displayed, whether it is by a load capacity plaque or a load capacity label, depending on the type of racks. You need to make sure that there is no disparity between load capacity plaque and the LARCs, just to make sure that everything aligns. And if there is any discrepancy, you need to have your capacities reevaluated. Missing LARCs, if you do not have your load application and rack configuration drawings, you must contact your OEM and you must get them, as they're imposed by both Canadian and USA building codes. Otherwise, how do you know if you're not overloading a system? Not knowing is not really an excuse in the eyes of law. It is your responsibility to have them. All right, now that we've gone through the summary, let's go over a quiz. So the way it's gonna go is I'll read the question and I'll give you a few seconds to think about it. And the chat is open, so you guys feel free to write your answer in the chat, or if you want to open your microphone and give out the answer, no problem, you can do that too. First question, can a rack be connected to the building structure? Yep, most of you got it. So the answer for that is no, unless it is approved by an engineer. So if an engineer and a rack designer approves the attachment, then it can be attached. Otherwise, no, it is not allowed. As racks are very fairly complex structures and the buildings as well, and you want to prevent any kind of potential damage coming from the bill or vibrations transferring from the building to the racks. What is the maximum deflection allowed for a 96 inches beam or 8 feet length of beam? So yeah, a few of you guys answered half an inch. That is correct. There, as you know, the rule is L over 180. So 96 over 180 is half an inch. So that's the maximum deflection allowed. Anything past half an inch is probably permanent deflection, and anything at or less than half an inch is probably just elastic deflection. So that's the maximum you're allowed. Should the rack be anchored to the floor? That's correct. The rack must be anchored to the floor. As you know, you must have at least one anchor per base plate, and in some seismic areas or based on the manufacturer, you might have two anchors per base plate, but overall, one anchor per base plate is a requirement. Can you modify or repair a pallet rack? So the answer for this is, as one of you answered, it is yes. You can modify or repair a pallet rack if you get it certified by a qualified engineer. Otherwise, no, you're not allowed to do that by yourself. What do you think about safety pins? Are safety pins mandatory? And if they are mandatory, how many safety pins do you need per each beam? So the answer for this one is yes, safety pins are mandatory, and you need to make sure you have at least one safety pin for each beam clip. So if every beam clip has every beam has two beam clips, so you need at least two safety pins for each beam. Last question: what do you think about safety bars? Are safety bars mandatory? So the answer to this is safety bars are not mandatory, but if you do have safety bars, then you need to make sure you screw them or you attach them to the front and the back as the code mentions them. And also if you have safety bars, you need to make sure you have at least two safety bars for each pallet position just to prevent product from falling through. So that's it with the quiz. These are the questions that I had. Now let's take a 10-minute break. Right now is 11:05. We'll come back in 10 minutes at 11:15 Eastern Standard Time, and then we'll go from there. I'll see you guys in 10 minutes. Okay, if everybody's back, let's begin the second major section of this presentation. So the second part of this presentation is how to prioritize issues. So before the break, we went through the fundamentals and went over how we can identify issues. And now we're going to figure out and understand how we're going to prioritize issues. So if you look at our rack safety flywheel at the top over here, before we discussed inspection, but now we're going to the inside component. For categorization, we have four categories that we use when we inspect. The goal that we have at Damotech is we want to try to keep everything as simple as possible. Some of our competitors, we know they use a range from 1 to 10. We think it is really hard to tell the difference between, let's say, a 6 and an 8, and it can be ambiguous. For example, you can have a very severely damaged issue and they give a priority of a 7, whereas for the same issue, you give a priority of an 8. But what's the difference between a 7 and an 8 or a 6 and an 8? We're unsure. So to avoid any of these ambiguities, we go with a 4 rating system. The first one is an unload. Unload means that you need to take immediate action. You need to unload the affected region and before taking corrective action, and you need to address the issue as soon as possible. So what that means is you remove the product, you cordon off, and you don't use. High is the second issue. High basically means the issue should be addressed as soon as possible, but you are still okay, not okay, but you can use that rack or that component, but be very, very vigilant and be very, very careful. Moderate means the issue must be addressed within a reasonable amount of time, and that time can vary depending on the product and the damage. But a moderate issue basically means you don't need to address that issue ASAP, but as soon as possible. And a low means no immediate action is required. So you just create a low watch issue. It could be that you just create an issue and keep a comment, and you reassess the damage within a year. So these are the 4 different priorities that we have. Unload being the most severe, low being the least. Unload high, moderate, and low. Starting off with unload, what I'll do is I'll go through examples and I'll show you guys examples of unload situations, and we'll categorize them. So in here you can see the column upright right here in the front is severely damaged. It's like a banana shape. It also looks like it's not attached to the floor, so either there was a missing anchor or the anchor is sheared. The damage is quite severe. You also see the horizontal brace is deformed. Sorry, the diagonal brace is deformed, and this horizontal brace is also deformed. If we want to follow the 1, 2, 3 rule for the column, for sure this is triple or 4 times greater than 1/8 of an inch and also 2/8 of an inch, because there's the deformation both ways. And if you want to follow the brace deformation of 3/8 of an inch, this is for sure double or thrice that amount. So by all means, this becomes an unload situation. Over here, you can see first thing to note is that the column is doubled. So anytime a column is doubled, which it means that initially it is much stronger. So if it came into contact with the forklift, and if there was damage and both the front and the back double columns were deviated, that means the damage was quite severe. So that indicates, hey, okay, this probably will be an unload as well. And also, if you follow the 1, 2, 3 rule, the frontal damage is frontal and lateral damage. 1/8 and 2/8 of rule, this damage is 3 times greater than that approximately. So for sure, this will be unload. As you can see, there's damage here and there's damage. And more importantly, anytime you find a column that has lost its shape, most likely it will go towards a higher an unload. Here, anytime a column is sheared, immediately it will be an unload just because it compromises and jeopardizes the load capacity. Beam right here is deformed quite significantly, and if you follow the beam's rule of 1/4 of an inch, this looks like twice or thrice the amount of deformation, and it's visibly pushed back into the bay, giving a clear indication of an unload. Similar to a column, if you see that the beam has lost its shape, then it's an indication it's going to be a high or an unload. Beam right here is pierced. Anytime a beam is pierced, it jeopardizes the load capacity, so immediately it's going to be unloaded and replace that beam. Here, it looks like the weld connection between the beam and the beam connector is either damaged or it looks like a manufacturer defects. Either way, it is going to be an unload because this jeopardizes the load capacity, and we don't know what kind of strength it has in it to hold and for how much longer it can hold the beam. Here, this is an example of a rust. As you can see, 1, 2, these beams are perfectly great, but this beam right here is just not galvanized. The rust is eaten through the bottom. Anytime rust eats through this metal steel is going to be an unload. And for this, we recommend that you install a galvanized beam, especially in outdoor conditions. Over here, you see that the column is completely out of its shape. As you can see, this column is coming down straight, and initially it should land around here. But this column is deviated towards the left. It looks like the forklift probably made a turn or the pallet made a turn and made contact with a column and shifted it to the left. Since it shifted, the anchor is probably pierced and the column is deviated quite a lot. Since it's out of straight and there's significant deformation, it's going to be an unload for sure. Here you see this is a prime time example. This beam right here closer to the floor probably is hit by, it could be a wheel, it could be some other component of a wheel, lift truck, but it was hit. And also the thing to note here is that the beam connectors pins are broken. As you see, it's broken here. This is about to break off, and if this breaks off, then automatically it's going to fall. So that's why it's going to be an unload, and you have to replace this beam. In here, we see a column, a C structure, a shaped structural column. As I previously mentioned, structural columns tend to be the strongest, and in here we see that the strongest of the column is sheared, so automatically it's going to be an unload. Here in this column, it's in the middle. It looks like this holding heavy product is being hit, and if you look at frontal damage, it's combined frontal and lateral, so it is twice or thrice 1/8 and 2/8 of deformation. So it's going to be an unload. Here, this is another typical example you find sometimes in warehouses. This it looks like the forklift, the wheel ran into the upright and it left an indent. And since the frontal damage is quite a lot greater than 1/8 of an inch, and it's lost its shape, it's going to be an unload. While we're talking about unload, I just want to discuss what's the safe unloading method. Let's say you have this upright column and it's lost its shape and it is deformed significantly and needs to be unloaded. What that means is the way you need to understand is that whenever you have, for example, you have this base system, whenever you have a pallet on each beam, uh, each upright holds a certain amount of load from that on that beam. So if that pallet is stored to the left of this beam, most of the load will be transferred to this upright, and if this pallet was stored towards the right of this beam, then most of that load will be transferred to this upright. And our target is that whenever we're unloading, we want to remove any load which is being placed on this column right here. So in here, we see that there's no pallet here, no pallet here. So no beam, no load is directly on top of this column. Likewise for the second beam level, but for the third beam level, there's no pallet to the left, but the pallet on the right, this load is being transferred directly onto this upright. So we want to move this to a location so that it is not adjacent to the upright. So what we can do is we can bring that pallet down from the top bottom so that from top to down, it is all clear and there's no load directly on the upright. And that's how you unload uprights. For beams, it's a bit different. Let's assume that you have beam right here, which has lost its shape and is significantly out of its shape, and it needs to be unloaded and replaced. For unloading, it's simple. You replace all the products off of the entire beam. So anything stored in this cell, you remove. All right, now that we've gone through the unload, let's go through high priorities. So these high priority issues are issues which need to be addressed as soon as possible, but they do not necessarily require unloading. If you look at this first picture here, we see that the column is laterally deformed. According to the 1, 2, 3 rule, if the column is deformed by 2/8 of an inch laterally, it is considered moderate. However, the deformation is well beyond double that measurement, then we'll classify this as a high priority issue. Right here, you can see this is an emergency exit, as you can see right here, and the beams is missing wire mesh decking. As I previously mentioned, only under tunnels, beams must have wire mesh decking. Since it's missing, it's a high priority. Here, we have two issues that you can look for. Number one, the beam has been hit from the bottom, and following the 1/4 of an inch of deformation rule for beams, this is double that amount. And also the beam clip seems to be bending inward. As you can see, the top and the bottom do not align perfectly upright. So with these two combined, it's going to be high priority. While we're here, you might discuss, hey, it is high, but can I bump it up to an unload? So the simple answer for this is whenever you're confused and we're unsure how to differentiate between a high and an unload, just understand one difference, that if you are already at a high and you are unsure what to do next, you can always bump it up to an unload to be on the safe side. Essentially, a high can always be an unload if you want to take a precautionary method. But just because if you have too many unloads in your warehouse, you will be limited on space. That's why we differentiate between a high and an unload, just to give you a bit more wiggle room, so that you have enough time to make your repairs in a timely manner. Some more examples, as you can see, this a doubled column has been hit from the front and it's bent, it has lost its shape, but it's not lost its shape significantly, but because both the front and the back columns are deformed, then it's going to be an unload, a high priority. Here, this is a subtle example, but I just want to show you. Over here, it looks like the horizontal brace is detached, as you see the gap. Through a naked eye, you might be like, hey, maybe it's detached just on this section, is connected to the other part. A quick test you can do in your warehouse or when you're inspecting, because everybody's wearing safety shoes and the front part is a metal toe. What you can do is, using the metal section, hit the bottom of the brace. And if you hear a sharp noise, that means the weld is broken and the horizontal brace is loose. That means you need to replace that component. If you hear a dull noise, that means, okay, the weld is present, but just this component is loose. In either case, the brace will most likely be loose. So you need to replace this horizontal brace, so high priority issue. In here, as I previously mentioned, through a naked eye, if you're untrained, you might be like, hey, there's no issue here, but in reality, the diagonal brace is missing. So anytime a brace, whether horizontal or diagonal, is missing, it's a high priority issue. In the first picture here, we see that the beam right here is deformed, double the 1/4 of an inch of deflection and is bent in multiple locations, like once here, and also through the crease line is bent inwards, so it's going to be high priority issue. So you replace that beam. Here you see that the horizontal diagonal brace is detached, it's not connected to the front column. As you can see, the connection is here. So since it's broken, it's going to be high priority and you should meet that repair. The beam here you can see has been hit multiple locations, 1, 2, 3 from the bottom as well. Falling the 1/4 of an 1/4 of an inch, it is double that amount, so automatically high priority, and you should replace the beam. Now let's dive into a moderate priority issue, which signifies that you should address the issue in a timely manner. This photo on the left is an excellent visual of what a 2/8 inch of lateral deformation looks like. According to the 1, 2, 3 rule, since this is at the 2/8 of an inch on the borderline, we'll classify this as a moderate. Here you see the anchor is missing, and anytime an anchor is missing, it's always a moderate priority issue. Unless the entire system is missing anchors. If only one column is missing anchor, it's going to be a moderate. But if every upright in the entire system is missing an anchor, it's going to be a high. But that usually is not the case. Here you can see on the left you have a beam and a safety pin in place, but on the right you have a beam, there's no safety pin. Anytime a safety pin is missing, it's going to be a moderate priority. And safety pins are mandatory. This again is another example of a standard 2/8 of an inch of deformation from the side of a column. Since it's at the borderline, we'll classify this as moderate. Beam right here is deformed from the bottom. This is the standard 1/4 of an inch of deformation on the beam. Since it's at the borderline, classify this as a moderate. We're going to the 1, 2, 3 rule for braces. If the brace is at least 3/8 of an inch of deflection, then it's going to be moderate. Since this is the case, it's going to be moderate. Now bumping up to low priorities, which do not require urgent, but just require attention in the long term. Here we have multiple issues. Number one, there's a clearance issue between the pallet and the column. You remember you need to have at least 3 inches of clearance between the rack and the pallet. So that's one thing. Second thing is the pallet safety bar here is not positioned correctly. It must be positioned underneath the pallet. So this needs to be removed. So these two issues are low priority. And next up, we have a column which has been hit from the side. According to 1, 2, 3 rule, 1/8 of an inch of deformation is slightly less than 1/8 of an inch of deformation, so it's going to be a low priority. Here we have a diagonal brace. Again, you can see a small nick right here. It is less than 3/8 of an inch of deflection for the brace. That's going to be low. You might be like, hey, can I fix this myself using pliers? The answer is yes. You can use pliers and fix this, but just be careful to not break any welds, because if you break a weld while fixing a low priority, you might create a high priority, which require you to replace the entire diagonal brace. One point of disclaimer I want to mention that it's always important to remember that, and anytime you have a lot of low priority issues, say for example you have one column that has multiple lows, lows can be combined to create a high priority issue. Again, this is a singular case, it's only for one location. But if you have different locations of different lows, then they do not combine. Now that we've gone through that, let's do a little quiz just to make sure we all got the crux and some of the main points. So similar to last time, I'll put out a question. I'll put out a picture. Feel free to answer in the chat or unmute and give me the answer. How would you classify this damage? To begin, I'll help you guys over here. The damage is focused on the beam. Yep, as you put in the chat, you guys got it right. Unload. This is going to be an unload. Clearly, the beam is deflected. There's multiple dents and it's lost its shape. So for sure, it's going to be an unload. And if you want to follow the 1/4 of an inch of deformation, this is twice or thrice that amount, maybe even greater. So automatically an unload. What do you guys think about this one? The column here is sheared.
Unload.
That is correct, as you said. It is an unload for sure, and also as you said in the chat, since it's shared, the load capacity is jeopardized, and we want to make sure we make that repair as soon as possible. So for sure, unload it is. What do you guys think over here? We want to focus on this diagonal brace up here. So for the diagonal brace, the previous discussed, the standard rule is the 1, 2, 3 rule. For the brace damage is 3/8 of an inch of deformation. This right here, it looks like it's at the borderline. I mean, it has lost its shape, and it is at just 3/8 of an inch of deformation. So I will classify this as a moderate priority. For generally, or to be honest, for horizontal or diagonal braces, we never, or not, I would not say never, we generally do not have unloads unless you have multiple, unless you have horizontal, diagonal, horizontal missing. But generally, that's not the case. Generally, majority of the time, the maximum rating we give to braces is a high priority. So that's why we don't consider that as a major component unless you have multiple braces which are missing. What do you guys think about this one right here? So for these next few slides, I'll let you guys guide your eyes. I'll let you guys identify the issues so that you can get some practice. So in here, this one is a moderate priority. As you can see, the column here is a lateral damage is just at 2/8 of an, sorry, it's just at the borderline of 2/8 of an inch of deformation, according to the 1, 2, 3 rule. So it's going to be a
Moderate.
yeah, that's going to be a moderate priority. Yeah. What do you guys think is happening here? And what priority would you guys give?
High priority.
A high is correct, but I will bump it up to an unload. Just because, as you can see over here, if you zoom in, the beam clip is not engaging with an upright, which means that the beam is loose, is disengaged. So that means if you place another load or at any minute, the beam can actually fall off and can injure someone. So that's why I'll bump it up to unload. So what you do is you unload the beam, you remove the product, you remove the beam, and then you try to engage the beam back into the upright. If the beam locks in and the safety pin locks in, you can then place the product back on and continue using it. If it's not, that means the beam clips are damaged and you need to replace the beam. So that's why this is going to be an unload situation. What do you guys think over here?
High priority.
Yep, that is correct. High priority. As you can see, it's doubled column. It's front and back, and according to the 1, 2, 3 rule, frontal damage of 1 greater than 1/8 of an inch. This is 3 times, approximately 3 to 4 times greater than that. It's going to be high. If you want to bump it up to an unload, feel free. That's also okay because you're always being safer. But a high is sufficient. What do you guys think here?
Unload now.
That is correct. So everyone in the chat on yourself got it right. Unload right away. Rust has eaten through the steel. Time to get that replaced ASAP. What do you guys think? What's happening here? This is a tricky one.
Corrosion.
There's a bit of that, but that's not the primary. I would say try to focus on this area right here. So what's happening here is normally you have an anchor, but in here, instead of an anchor, what they're using a pin or a nail and a washer. For some reason, they thought that by installing a washer and a nail, you'll hold the rack in its place, but that's not the case. So this is insufficient, it's inadequate. So in this case, an anchor is missing. That's how we treat it. We don't even consider this as anything other than an anchor. So a missing anchor is going to be a moderate priority. What's happening here? What do you guys think for the beam?
Low.
Yep, that is correct. The camera effects may have accentuated the damage here, so it looks like it's worse, but it's actually very low because, you know, the beam is straight from the top, means the beam has not lost its shape even at the bottom edge. Since there's no loss of shape, it's just very, very low issues. Just the camera angle has made it look a bit more than the usual. So that's it for the quiz. Now we'll go, and that's it for how you categorize issues. So two major chunks of this PowerPoint presentation that we want to discuss was how to identify issues and how to categorize issues have been completed. Now we'll go into the other secondary components of the presentation, which is how to develop your own inspection protocol. So getting this training course here is the first great step. As everyone now in this training, all the participants are now more aware of what to look for and how to rate these damages in order to address them in a timely and orderly manner. But now I'm going to show you how you can develop your own protocol at your own facility. So to develop an inspection protocol, there are a few things you need to address. Number one, how many times do you want to do the inspection? Then who's going to inspect? What are you going to report on? And what kind of records you want to keep? Starting off, in terms of frequency, you know, many governments will say a yearly inspection by third party makes sense. An independent set of eyes coming in the facility, writing an independent report for their observations. In our case, Damotech, we are a third party. So when we come in, our people are trained rather uniformly. So we follow the latest codes. We're the member of the RMI in the States as well. So we know our business and we have seen thousands of different warehouses across North America. So monthly inspections by trained warehouse employees also makes sense. It depends on your situation, like your own velocity of operation and maneuverability. In terms of reporting, you should have an ongoing reporting or maintenance program. We'll give you some more information on I'll give you some more information on the paperwork of that in the next few slides. The last but not least, you should have a document control in place to ensure that your audits, your modifications, your repairs of the racks are all up to date and they're stored correctly so that you always have them on hand whenever they're needed. In terms of records, what to keep and how to keep them, first and foremost, you need to make sure your LARCs are up to date. Again, LARC stands for Load Application Rack Configuration Drawings. These are essential documents that tell you the overview layout of your rack and the load capacities. Next, you want to make sure your regular inspections, which are critical, and you want to keep their records. As we discussed, a yearly inspection by an external third party is recommended compared to an ongoing monthly basis inspection. Next up, you want to make sure any type of employee training records are kept. This is important just to make sure everybody's on the same page and you know who's missing out on what kind of information. In terms of the last some other documents you need to keep are document repairs, because anytime you make a repair, the load capacity may be changed. So you need to keep a documentation so that when an engineer comes in, he's aware of the repairs. Likewise for modifications. Anytime a modification is made, repair documentation must be kept just to make sure the capacities have not been changed. And if they have been, then new capacities can be given by an engineer. Inspection comes with tools. So what are some of the tools you need? So first and foremost, you need an inspection checklist. We at Damotech, we have developed an inspection checklist that you can use. It is rather easy because in here you can write the location, you have the date. So this is great because for this inspection, you have the inspector's name, you have the sheet number, you have the frequency, and everything is already set in stone. So you can use this from our website. It's at damotech.com/resources. You can use this to carry out your internal inspections. How you can use the inspection checklist, I'll go through an example. Let's say we have a damage that we have located, it's right over here, that the column is damaged, and we want to record this in the inspection checklist. First thing first, we'll identify the location, and we'll read the location to the right of the upright. It says 201 10101, so we'll put that up. Then we'll identify the component which is being addressed. In here is the upright, so we'll put the column. Since it's the front, we'll put a 1, and for the back column, we'll put a 2. And then we put the priority. For priority, we put unload because, as you can see, it's severely detached and it's not connected to the floor. And then we leave a comment cordon off. Another example, right here, we see that there's a diagonal brace which has been, there's a small damage on the diagonal brace. As I previously showed you guys, it's not a severe damage. It looks like a low damage from the examples before. But first thing first, we put in the location, and let's assume the location is 7-11. Then we identify the component. It's a diagonal brace of height 2. This is the height 1. This is the height 2. So we go braces. We go D for diagonal and 2 for the height. And then for a priority of a low. Likewise, here we have a beam. As you can see, the beam is deformed quite badly. So first thing first, we put in the location, DA 405-D1, which we get from here, to the left of the beam. And then we put in the beam height. And it looks like 1, 2, 3, 4. Can't really see all the beams in this picture. So for the beams, we put the height as 4. Then we put the priority. It's going to be an unload. As you can see, the damage is significant. Then we put a comment. And that's how you can use the inspection checklist from us, from Damotech, which you can download from damotech.com/resources. Aside from the checklist, some other tools I recommend are a flashlight, which comes handy in dark areas, a measuring tape to measure everything, level, torpedo level just to check for verticality, and a notepad on the checklist. Next up, some of the solutions for repair. Let's talk about ways you can keep yourself and the people around you in a safe environment and in top-notch condition. Maintenance. Sorry about that. Let's now dive into maintenance and explore the approaches you can take to address any high or urgent priority issues in your rack systems. You essentially have two options when it comes to repairs. Either you repair the damage or you replace the damaged components. I will go into a bit more into detail on these in the next few slides, but as you weigh your choices, there are a few factors you want to consider. One of them is the manufacturer's cycle time, and the other one is your operational efficiency. So for manufacturer cycle time, for example, if you want to replace the upright, it could take months, where repairs can be faster. And impacts on the operations, do you need that space? If you need that space immediately, maybe repair is the way to go. If you're okay with the space, then you can go with replacing the entire upright, which may take longer. So let's consider one of the two scenarios where you need to replace a damaged upright. When opting for replacement, it's crucial to ensure that the new upright is exact match as the damaged one, which means that the columns, the horizontal, the diagonal braces, the base plates, and the thickness, everything must match the exact upright that you're replacing. If any of these components or elements do not align with the component being replaced, you risk invalidating your load application and rack configuration drawings, which means you need to reassess because your capacity have changed. So that's why it's very important whenever you replace a component, everything matches. If you don't want to replace and you want to repair using a repair kit, then here's an example of what we offer at Damotech. On the left here, you see that this upright was damaged, and we from Damotech, we came in and made that repair. A few pointers I want to mention is that for our repair kits, we offer a lifetime warranty, and we have a rather fast turnaround when compared to a purchase of a new upright, which takes about 12 to 18 weeks. When we actually come in, we install on average about within 45 minutes. We have a device that holds up the racking while we cut off the damaged portion. And our solution fits every type of pallet rack, no matter the size and style. So there's no on-site welding, of course, and most importantly, it will maintain the original load capacity of the system. Let's talk about some ways to keep you and the people around working daily and your racks in top-notch condition. One of the most important solutions to try to minimize dangers, and keep everybody safe in the warehouse is to take a look at the culture and perhaps introduce some culture changes. Also, you want to make sure that you conduct employee trainings like the ones we're doing today. Of course, helps. And housekeeping to keep products off the aisles. And you also want to make sure that you view your racks as assets. That's a big one. If you view your racks as assets, you'll actually save thousands of dollars because racks are inherently what are holding your products. If your racks are damaged and they do collapse for any reason, then your products will also get damaged. So that's what's very important, that you view your racks as assets. Anytime you have impact, any damage on the racks due to impact, you need to make sure you report that, so address in a timely manner, and more and importantly, make sure you conduct internal inspections regularly. In our ongoing efforts to enhance warehouse operation cultures, one of the primary solutions we are introducing today is called an aisle manager sign. A common challenge we find in many warehouses is the blurred lines between accountability when it is not assigned. So this can lead to situations where you have tasks which should be everybody's responsibility end up being neglected. To address this, we have developed a warehouse aisle ownership sign. So by placing one at the end of each warehouse aisle, it clearly designates an aisle manager, ensuring direct responsibility for their rack system. If you are interested in implementing this, a template is available to download on our website. Moving on to more safety solutions is crucial to ensure both people and products are protected in the warehouse. So one of the primary concerns in any warehouse is the flow of forklift trucks. With pedestrians and staff moving around, it's vital to ensure their safety. While not as widespread as we like, incorporating mirrors and gates that can significantly reduce the risk of accidents. These tools, they provide better visibility and controlled access, acting as a safety precaution against potential collisions. Another area of focus is workstations. Sorry about that. I just want to point out that another area of focus is workstations. You want to make sure whenever you're installing workstations, they are away from forklift traffic, just to avoid any injury or just to avoid any accidents. Now what I'll do is I'll go through some protection solution that we at Damotech offer. On the left here, we have a Damo end guard. This is specifically designed to protect the vulnerable ends of aisles from forklift damage. It is made up of sturdy 3/8 inch thick iron and is reinforced with stiffeners to ensure robust protection against impacts. And the picture on the right, you can see beautifully lined up Damo guards. These Damo guards prevent and protect the bottom of columns for impacts. And what our analysis have shown is that our Damo guards prove to lower the stress induced into the column by a factor of 6 from frontal impact and by a factor of 9 on the lateral impact. And it stands as one of the best in the markets. Next up, we have a Damo shield. This is not just any column protector. It is a pinnacle of building column protection. Whether it's forklift, fork troughs, or other machinery, Damo shield is designed to withstand and absorb impacts. What sets ours apart is that our Damo shields are installed to the floor and not to the column. So anytime there is any damage, it takes in the damage and transfers to the ground and not to the column. So the building column is kept safe at all times. Now here are just a few reminders and takeaways I want to discuss. Number one, all damage reduces load capacity, and it is very hard to figure out how much. Therefore, we're recommending fixing a damage as soon as possible. Anytime you have an issue, make sure you report all the issues and address the damage as soon as possible. Of course, in a perfect world, all the damage will be fixed, but in reality, as you know, you have limited amount of time and money. So that's what's so important. You prioritize based on the criteria we have discussed in the slides. And another one, you make sure you develop your own inspection protocol and conduct regular inspections. And whenever you're in doubt, it's best to just unload, because by unloading, you know you're safe 100%. All of the mentioned tools in the presentation are available on the website, so you can go on damotech.com/resources. Also, if you want to read a bit more into uprights, we have blogs and we have knowledge-based content for you to explore. With that, that concludes the rack safety training. Thank you everybody for listening. Now, if anyone has any questions, the floor is open, and I'll wait for everyone to leave once the questions are done. Thank you and have a great day.
From
Sounds good. Just one thing, Kayla, if you can please send me the list of everyone who attended the training so we can send out the certificates. Perfect. I really appreciate that. Thank you guys. Take care. Bye.